But welcome everyone. We're really happy to have you here to learn a little bit about different astronomy programs here in San Diego County and the STARTastro program, which is right over my head. When I'm going to head and start the slides up, and then we're going to do a quick introduction. There we go. All right. So before we start, Kate, do you want to comment on this for the MESA students?
Yes, you're invited to use this QR code. If you are possibly being awarded extra credit for attending this session, this is your QR code for that. And thank you, regardless of the extra credit. Thank you for being here.
All right, I'll give folks time to snap their photo.
It'll be up in the end again too.
Okay. All right. Okay, so let's go ahead and start with introductions. And I think, Karen, you're going to introduce yourself first.
Yeah, so hello everyone. My name's Karen Sandstrom. I'm a professor at UCSD, and I am an observational astronomer. I study the interstellar medium and star formation in nearby galaxies. And this is a really fun topic that lets me use telescopes from all the way from the radio part of the spectrum all the way to the UV. You can see me here, classic telescope picture with the Very Large Array in New Mexico. And I've been really honored over the years to work with some excellent students who transferred from community college. So I'm really excited to talk about those possibilities with you all.
Thanks, Karen. So hello, everyone. I'm Adam Bergasser. My pronouns are he, him. I'm professor of astronomy and astrophysics at UCSD, and I'm also an observational astronomer. I also use all sorts of fun telescopes, mostly optical and infrared telescopes, to study the smallest stars, extrasolar planets, and things in between called brown dwarfs. And I'm particularly interested in spectroscopy, so I do a whole bunch of different optical and infrared spectroscopy to study atmospheres and binaries and stuff like that. In addition to my science work, I also do a lot of teaching or sort of education research, and then I'm interested in outreach and science art. So there's a nice picture of my galaxy garden we built about a few years ago in Balboa Park. And Kate, I'm going to bounce it to you.
Yes, hi everybody. I'm Kate Rubin, she, her. I'm a professor of astronomy at San Diego State. I'm also an observational astronomer. I study gas flows through galaxies and through their large-scale environments. So gas flows are really important for feeding star formation in galaxies. And my work is focused on trying to figure out their role in galaxy evolution. I also really love spectroscopy, but I'm more of an ultraviolet optical spectroscopist. And I love using that kind of data for studying chemical composition, Doppler motion of gas, that kind of thing. I am also the director of the SDSU Training Astronomy Research Scholar Program, or STARS. I think there's at least one STARS alum in the audience today. Hello. Which has been focused on both community college and high school students training, and it's kind of an intensive astronomy boot camp in the summer. So I'm really excited to expand along those lines with the STARTastro program.
All right. I think it's on to me. So the next thing we wanted to talk about is give you a little bit of an intro to what astronomers do and why you might want to pursue a bachelor's degree of some sort in astronomy and astrophysics. So to begin with, this degree is a very broad one, right? So you're learning, you're working in a STEM field, you're learning a lot of really valuable skills in research and in, in the physical sciences. And so there's actually a huge range of things that you might possibly want to go into after a degree in astronomy and astrophysics. So one possibility is continuing in academia and going on to graduate school. And there's been quite a few people who I've met over the years who've gone from community college to a four-year institution and then on to graduate school in whatever field they're interested in. We have some excellent people on our panel, in fact, who are going to tell you about that path a bit. But there's many other options. So you may decide that rather than teaching and participating in an academic institution, you're more interested in research or working at an observatory, that kind of thing. So there are many possibilities there. In addition, there's more opportunities to use your knowledge that you gain about science to participate in things like scientific journalism or policy. And there's various opportunities to go from a bachelor's degree to careers in that kind of area. And then, of course, beyond the working in policy or journalism, academia, that kind of thing, there's huge worlds of industry where the research skills that you learn in a degree like this could be very relevant for many different areas of research in scientific areas and in other technical areas. So there are many opportunities for what you can do with this degree. And if you're interested in such a degree, we'll go ahead one slide. I think there are a lot of opportunities to do this in San Diego. So that's what we're here to tell you a bit about today. And I think from here, I pass it over to Adam.
Yep. All right. So we have two great opportunities we're going to talk about, and that's the two astronomy undergraduate programs here in San Diego. First one I want to talk about is UCSD, in part because it's the baby. It's the newest program we have. The program is actually just started, the department just started this year, and the undergraduate program will be starting just this fall. So in fact, we're currently taking in our first transfer class of community college students this coming fall. We have 15 faculty in our department, and they span a wide range of different areas, from observation to theory to computation to instrumentation. And we're actually hiring some more faculty, so we may actually be even bigger when the fall comes around. And then our program has access to two main observatories. One is the Lick Observatory, which is up in San Jose, California. That's one of the oldest observatories in the country, but it has a nice modern telescope, and we do a lot of science with that all the time. And then the more well-known observatory is the Keck Observatory, which is in Hawaii. And all of us, to some degree, use either Keck data or obtain new Keck data on our own. But in addition to that, we also use all kinds of other facilities, including facilities off the planet, like James Webb Space Telescope and HST. So the astronomy program, again, which is starting up this fall, will have two degree tracks. One is a Bachelor's of Science degree, and that's kind of ideal, as Karen was talking about, the path if you're thinking about academia, or you're thinking about industry, or something where you would need a graduate degree. The Bachelor's of Science degree is a good target for that. But we also have a Bachelor of Arts degree, which is ideal for folks who maybe are interested in astronomy and want to do a science degree, but maybe are considering other avenues of their career. So that might include teaching or even other areas of industry where a Bachelor's of Art would be preferred. So you can learn more. There's a QR code there if you want to look at that program. I'm going to pass it now to Kate, who's going to talk about SDSU.
Yes. So we're the elder of the two departments. We've had an astronomy major at San Diego State for many, many years. And we've accepted many community college students as transfer students over the years. We'll be accepting our next class for fall 2025. Some of you may have been admitted for fall 2024, which is very exciting. And I think your deadline to tell us if you're coming is coming up next week. At San Diego State, we have 7 astronomy faculty working on a range of science areas. And we also have our own observatory on Mount Laguna. And students, because the time at the observatory is distributed across mainly just our department, students have a lot of access to Mount Laguna. We have several telescopes up there that are used for both science and outreach. And students are constantly going up there for both outreach activities for classwork, etc. Our program offers also both a BS and BA degree in astronomy, and they're kind of aimed at the same directions as Adam was describing for their BS and BA degrees. You would go for a BS degree if you're looking to go to graduate school in astronomy or going into a technical career. A BA degree might be more appropriate for a teaching career or science communication, outreach, etc. You can use this QR code to find out more about our program. And the undergraduate advisor in our department is Dr. Jerome Arose, who is also on this call. And if you happen to have any questions for him immediately, I think he'll be around for the QA toward the end. And you can also contact him at this email address here.
Jeremy, you want to say hi?
Hello, I'm glad to be here. As Kate said, I'm the undergraduate advisor, and so certainly get in touch or ask questions if you want more information.
Great.
All right, so I think the next thing we have lined up is a panel discussion. We've got three awesome panelists who are going to briefly introduce themselves. And then we have a series of questions for them. So we're going to spend a bit of time on this, and then they'll also hopefully be around at the end if there's any questions in the Q&A period. So would you like to introduce yourself first, Nis?
Sure. All right. Hey, everybody. I'm Nis. I'm a first-year master's student at SDSU. Before that, I went to Pasadena City College for 3 years, then transferred to UCLA and graduated in 2022 with a astrophysics major. And currently, I work with Kate on modeling these structures in the halos of galaxies, which is really fun. So,
Great, thank you. Ryan, would you like to go next?
Certainly. Hi, I'm Ryan. I'm finishing up my graduate studies at UC San Diego, but I started pretty much at every community college in San Diego. I've been a student at Grossmont, Mesa, and San Diego City College. After that, I transferred to San Francisco State University, where I graduated in 2016 to attend the master's program at San Diego State, working with Professor Kate Rubin, and then transferred to UC San Diego, where I've worked with Professor Karen Sandstrom, working on measuring the physical properties inside star-forming regions in nearby galaxies.
Awesome, thanks, Ryan. Chris, would you like to introduce yourself?
Sure. Hi, everyone. I'm Chris Dyson. I'm an assistant professor at UC San Diego. I, too, have sampled many of the community colleges in San Diego. So I went to Mesa, I went to Miramar, I did a little time at Grossmont. So I have been around, and I am, a product of all that San Diego has to offer. So I can help discuss some of the pitfalls that befall students when they go from community college into a four-year university. I study lots of different aspects of very low mass stars and brown dwarfs. I'm very interested in planets and planetary habitability, lots of different observational aspects of small stars.
Great. So the first question we have for you all, and I think you should kind of feel free to just jump in when you have an answer you'd like to contribute, is how is the climate and culture of a four-year institution different from a community college? So I know it's a big one.
I can go ahead and tackle that first. One of the first things I noticed making the transfer is that at community college, there's so many different students working on different things. So when you're taking these lower division courses, I found it tough to make friends, especially because I was also working full time. But once making it to the four-year university, all of a sudden I was thrown in with people who shared similar goals. And so definitely, felt more part of the community than I did at community college.
Just
Yeah,
to
I'll
chime in, sorry, if you want, you can, okay. Um, yeah, I definitely agree there. There was a much more tight-knit community transferring to UCLA personally. I also transferred like right at the height of COVID. So classes were completely online. And because of that, a lot of the incoming class took it upon ourselves to try to befriend each other over like things like Discord or any other online chats and stuff. And it ended up working out really well because once classes got back in session, we all basically just got to meet each other and the community just like got really, really tight knit. It especially helped that on campus there was an undergraduate lounge. And so a lot of us just became regulars at the lounge and formed very deep friendships there. So it was very, very different from the community college atmosphere where a lot of people were just commuting to classes, taking them and going back home.
Yeah, so I'll echo a lot of what was said. Community was paramount for me. There's a lot of people who are going to transfer in with you, and I found the pacing to be a lot different going from community college to a four-year college. So, a lot of the struggles I was having, everyone else who transferred in was also having. So finding that community and bonding over kind of these struggles was really important. And we formed study groups, I think similar to what a lot of people here mentioned, and finding people who have similar interests to you. There's usually clubs that have specific interests, and I think anytime you can find communities that have these shared interests, it can help make the transition a lot easier.
Great. Thanks very much. So next up, we had a question. What led you to pursue a degree in astronomy? And maybe how did you come to that idea at community college? And yeah, very interested to hear what you have to say.
I'll start because I was the last one on the previous question. So when I was at community college, I kind of sampled the whole buffet. I tried everything. I was a philosophy major, an English major. I thought I'd go into law. I basically tried a little bit of everything until I hit physics. And then physics just kind of resonated with me. It's hard to explain, but I just found immense beauty in trying to quantify every aspect of, life. And that's basically how I've been living my life since then. Everything was an optimization problem, and here was physics, which is basically trying to solve optimization problems for everything. So it was a wonderful way to live my life. And then I would say, I narrowed down to astro through a few different things. I think the first thing for me was reading Stephen Hawking's A Brief Introduction to the History of Time. And it was just kind of an amazing book. And the first time I saw the Hubble Deep Field, that was like very moving for me. But it wasn't until I had some research experiences where I was doing observational astronomy that I really found a passion for astro. Like being at a telescope in the middle of the night, there's nothing quite like it, I would say.
Nis or Ryan, would you like to add to that?
Yeah, I can add. So when I was, very young, I really liked the weather, tornadoes, volcanoes, and of course space. But somewhere along the way, I got more interested in being in a rock band. So when I graduated high school, I actually had no real intention of going to community college or college in general. But once I realized that I wasn't going to get famous my senior year of high school, I decided to go to school for music, where I unfortunately dropped out. But in between, or like shortly after, I've been watching a lot of Carl Sagan's The Cosmos on the Discovery Channel. And I think I just made a decision to go pursue astronomy, not really understanding what that decision entailed.
Yeah, the same thing basically happened with me where I had a completely different career goal in high school, but coming out of it, like I completely switched to wanting to do astrophysics without really thinking about what that entails. But as I continued my studies, I ended up really liking it and stuff because I had the very great opportunity to actually do research the summer before I transferred to UCLA, only through connections with a community college professor. But yeah, it was honestly great and probably one of the greatest decisions of my life because I really like this. Yeah, if anybody has any questions about like the full long story of it, just feel free to ask.
Nice. Well, we'll definitely have an opportunity for that full long story maybe at the end. So next question for you all. What is or was your favorite part of being at a four-year institution, and what is or was the biggest challenge?
I think my favorite part about going to a four-year institution is that by the end of it, I really felt like I had accomplished a goal that I had set out to do, and felt, for the first time really knowledgeable about something. And that was just, a great boost to my confidence. But one of the challenging things, and I alluded to this earlier, um, from community college, I really was focused on just getting a bachelor's degree. I didn't really understand that to, be an astronomer, you had to go to grad school, and that meant you had to do research. You had to, write papers, hopefully to, boost your grad school application. So I think the challenge for me was that I really had to catch up. And so, most of my senior year, I kind of felt behind in terms of student research accomplishments. But, in the end, I ended up focusing a lot more on research because of that. And then, I've had great opportunities to study at, really good institutions.
Great, thanks, Ryan. Chris or Nis, any additions?
Yeah, so I would say definitely the research opportunities. There research opportunities in community college are few and a little harder to come by, I would say. Whereas going to a four-year institution, that's kind of one of the major draws. And we don't advertise that enough, I think, because a lot of students don't know that it's available. They don't really know how to get a research opportunity. I mean, a lot of times it's just asking professors, emailing professors, but that's a scary thing for them to do, but it's perfectly normal. So if you take a class with somebody and their research seems really interesting, it's totally fine to ask them, are you looking for an undergrad researcher? I would say that, the hardest thing for me was probably not trying to do too much. I've always been somebody who kind of like says yes to lots of things, and there's classes, there's homework, but there's also research, there are clubs, there's leadership opportunities. It's kind of choose your own adventure, I would say. Once you enter a four-year institution, there's just a lot of opportunities, and you kind of have to pick which ones you're really interested in and try not to overload yourself.
That's good. Mm-hmm.
Yeah, just to echo what everybody else just said, like my favorite part and also the biggest challenge is indeed exploring your interests, because like at a four-year institution, you get to like talk to so many people who are interested in the same things that you're doing, and you're able to actually go out and look at really what intrigues you or something that you would want to pursue a career in. But the big challenge of that is actually kind of biting the bullet and talking to professors, because that can be very intimidating. And also just finding a good research opportunity in general, especially with how competitive that can be in a lot of institutions. I personally kind of got really lucky with getting research, but I know many of my peers who had trouble with getting that. And so I definitely agree with Chris' point about how it kind of needs to be, or like advertised or explained more, which is why it's kind of great that there like programs like this and also mentorship programs throughout a lot of institutions are now popping up that could help students out.
Awesome. Thanks for that. So as we wrap up, the last question we have for you all is if you gave a piece of advice to students who are about to transfer into an astronomy program, what would it be?
I would say go to every office hour that you can.
Good one.
Absolutely, yeah. Definitely do not be afraid to talk to your professors.
100%. Don't be afraid.
Yeah, I'm just gonna echo that. I mean, don't be afraid, and that goes across the board. Don't be afraid to ask questions. Don't be afraid to interact with people, your professors, postdocs, researchers. You know, interaction is part of this whole process. So the more you interact, the more people know you. That can only serve you better in the future when you like ask for research opportunities, when you know, say that you need an extension on an assignment, when you ask for recommendations for grad school, basically anything.
Awesome. So I see one question. Thanks very much to our panel. I don't know, Adam, did you have something to say?
Actually, Jerome has an answer.
Oh,
Not a
an
question.
answer.
Well,
Okay.
I have some more advice. I mean, when people come up to me and say I'm full of it, they mean advice. So if you follow me around with a chess clock and sort of record what I'm doing, most of the time I'm staring at the wall or sleeping at the desk, teaching. But apart from that, I'm writing code and I'm writing words. And so don't overlook, basic literacy, skills in writing, and then just basic coding. Nobody, no job interviewer is going to turn you down and say, you've got too much coding, we can't use you. And so, and then, literacy is important too, because I do a lot of writing.
Yeah, great. Well, thanks everybody. We're going to have a Q&A at the end. I think now we're going to get back to some slides and I think it's Adam's turn to tell you, or no, sorry, Kate's turn to tell you a little bit about life as an A&A major.
Yes, and give me just a moment because I can't seem to get back to my particular thing. So hold on one. Oh, there we go. Okay. Lots of windows, lots of windows. Did that go to the right place? Nope.
No?
Let's try again.
I can also do it if you want.
There we go.
Okay.
So a little bit of what life is like as an astronomy and astrophysics major. Our institutional experiences, we've talked, and it seems like the experiences are pretty similar in terms of the academic requirements for completing an A&A degree at both UCSD and SDSU. The majors are set up so that once you transfer in, you should be able to finish in 2 years. In your first year after transferring, at both institutions, there's a requirement to take a kind of introductory astronomy course that is aimed at the sophomore level normally. But since you won't be here yet in your sophomore year, that ends up transfer students do end up needing to take that in your junior year, which is a little annoying, but it seems to be, doable for our students. And then in terms of upper division courses, we have requirements that you take a course in stars and stellar evolution, and then a course or 2 in galaxy evolution and cosmology. If you're pursuing a BS degree, there's a requirement for a few additional upper level physics courses, and they can include things like electromagnetism, thermal physics, quantum mechanics, etc. The precise requirements at the 2 institutions are a little bit different, but they have a lot of overlap. There is also a requirement to take an upper level astronomical techniques course at both institutions, which involves a lot of training in Python in particular. At least that's the case at SDSU, probably also the case at UCSD. Maybe Adam can confirm. But training in coding that's required for doing research, and as well as in doing observations and in astronomical instrumentation. So that's kind of a summary of the coursework, and we're happy to answer any questions about that toward the end. Another part of the experience is getting involved. Of course, doing research, which we'll talk about more in a little bit. But there are also many outreach opportunities for upper level undergraduates at both institutions. We both have some kind of planetarium that's used for planetarium shows for the general public or your fellow students. And we have very active clubs in astronomy. We have the Schwartz Astronomical Society here at SDSU. We also have an astrobiology club at SDSU, and there are similar opportunities at UCSD. So it's coursework, it's outreach opportunities, it's joining clubs, getting together, learning things that you have interest in with your fellow students and faculty. And then, of course, getting involved in research. I think.
Okay.
Yeah.
All right, so let's dive in a little bit on the research that Kate mentioned at the end, because I think, and that was something we heard a lot in the panel, as one of the great benefits of going to a four-year institution is that there's more opportunities to pursue research, and to some degree, it's also expected as part of your education to kind of get involved in hands-on analysis and data as part of learning what astronomy is. And so in both of our institutions, we have a wide range of different areas of research. So all three of us have already mentioned that we're observational astronomers. And I like to think that means we get to go to telescopes, although increasingly sometimes that's going to our TV screens and watching the telescope remotely. But we do get a chance to go to some pretty amazing places to collect our data. Some photos there show a picture of the Keck Observatory. It's not really that small. It's just a projection effect. And then the other middle telescope is actually up at Lick Observatory. So it's a couple students learning how the instruments that are hanging off the end of telescope work and how they're operated. And then the last picture there is actually up at Palomar Observatory, which is here in San Diego County, which unfortunately UCSD and SDSU don't necessarily use ourselves, but sometimes we get a chance to use it with collaborators. In all these cases, we are actually on site using the instruments, checking out how the night sky works. And then, that data becomes a brand new set of information that we get to analyze for the first time. Many times that when our students are going to the telescopes, they're seeing stars or measuring them for the first time. No one's looked at the star in that way or made that measurement. And so because it's such a big universe, we're constantly making brand new discoveries. And Kate?
Yes, so other astronomers are what we call theorists. And what theorists tend to do is build models of some kind of physical process in the universe. So they might make a model of how they think a galaxy is forming. And then they write a lot of computer code to try to calculate that formation over time. And they run what we call computer simulations. Sometimes they're run on supercomputers to try to follow the formation of that galaxy as it changes over billions of years. And this kind of study is so important because as observers, we cannot watch that process. We cannot watch a galaxy change and grow over billions of years. We only see it at one snapshot in time. So this is a really, really important way of doing research. And so at our institutions, we have theorists working on galaxy formation models, like as I was describing. These are some images from those kinds of from simulations that model galaxies over billions of years towards the lower left in the slide. But you can run simulations and build models of all kinds of different situations. You can model the formation of planets around newly formed stars. You can model the formation of stars out of big clouds of gas. We have a faculty working in those areas as well. And so as a student working with one of those faculty members, you would be getting involved in writing code or analyzing some of these simulations.
Great. So another area where a lot of research is happening is in building the instruments that we put on telescopes to go make the measurements that people like Kate and Adam and I are interpreting. So this is a super important area of astronomical research. And it's really interesting because it actually combines a lot of skills that come from different fields like engineering and design and computer science, sometimes various things. So this is all brought together, and you can actually work on physically constructing things in labs, for instance, which is a different take on research than you've heard about from a theoretical simulation in a computer, or using a telescope somewhere in space to take an image of a distant galaxy, for instance. Here you might be actually constructing the components that go into this instrument. So we have a lot of people in the San Diego area who are working on this kind of thing. At STSU, there's folks who build instruments for Mount Laguna Observatory. And you think about that angle. At San Diego, or at UCSD, we have a big group of people who are working on the Simons Observatory, which is a telescope in a series of telescopes in Chile that will be observing the cosmic microwave background. And we also have a huge optical and infrared lab where people are building really amazing instruments for telescopes like Keck and Lick. So there are many opportunities at kind of all stages of the instrument design and building process, including commissioning it once it's on the telescope to get data. So this is another exciting path. So at this point, I think possibly you might be interested in how you get involved in undergraduate research, which we have some advice for you at both institutions. So in general, there's kind of 3 ways to approach this. And you can do all of these at some point during your time at either institution. So at UC San Diego, we have options for people to get academic credit during the quarter for research. So this would be through independent study or independent research course, Astro 99 or 199. 199H is for like a senior project. So if you want to do this, you arrange in advance with a faculty member, and you have to apply for this credit before the end of week 2 of the quarter with your faculty mentor who you've discussed the project with. And this can be either a 2 or 4 unit course. The other opportunity is to apply for a scholarship. And this is something, that you shouldn't be intimidated by. There are a lot of possible scholarships, and they are very eager to support students who are coming in, especially from community college, to access these kind of research opportunities. So one of these is the Triton Research and Experiential Learning Scholars Program, where it's a $1,000 scholarship for the quarter, and you propose a project in collaboration with a faculty mentor. So if that's something you're interested in, the next deadline for those will be in mid-October for the winter quarter next year. And of course, you can always volunteer to work in a faculty with a faculty mentor or a postdoctoral mentor or a research scientist or anyone who's doing research who can supervise a student throughout the department. So this is something that you can, get in contact with people at any point by emailing them, by going to their office hours, by talking to them after class. There's a lot of possible ways to approach a faculty mentor for that. Just to note, there's also a number of summer opportunities listed here, including the one we're going to tell you about at the end of this discussion. And if you would like more information, the QR code listed here will take you to a full list of research opportunities through the Undergrad Research Hub. So we can now, hopefully everyone's gotten their chance to take a picture there, but the slides will also be posted on our website at the end. So Kate, take it away.
Yes, so there are some similar opportunities at SDSU. You can do research for credit by just talking to a faculty member. Don't be afraid, just talk to us. You can reach out via email or just talk to us after class, as Karen said. And we also, if you're an astronomy major, we have a requirement that you do a senior project. So research is actually required as part of the BS degree. So in order to finish your degree, you will need to reach out to potential faculty mentors. A really good way to get started on research is to maybe ask about volunteer opportunities in the semester before you'd like to start earning credit. And that way you can get up to speed with your project when you start earning credit in the next semester. We also have several scholarship opportunities at SDSU. Transfer students are eligible after they've been here for one semester to apply for scholarships, and you should all apply for scholarships. We actually are very fortunate to have quite a bit of scholarship funds thanks to some very, very generous donors. And this year we were able to award more than $50,000 to 7 students who are majors in astronomy. So everyone who comes here should definitely apply for a scholarship. Go ahead. I don't know what's next.
That's
Yes.
amazing. Okay, $57,500. Okay, well, so we wanted to focus at the end here on one of the programs that we've just started, and that's what the name is on my screen here, is the STARTastro. And that is a program that just began literally this spring. We're just ramping up for our first class this fall. STARTastro stands for the Summer Transfer Academy and Research Training in Astronomy and Astrophysics. It's a mouthful. But it's a program that is really meant to support community college transfers into both SDSU and UCSD, and support both the transition going from community college into the 4-year program, but also continue to support through the academic year, through academic support and guidance and advice as you're progressing through your degree. So the individual components are an 8-week program, which is essentially 2 weeks of kind of concentrated academics and research skills. So you're developing some of the skills that you need to jump into that research, as we talked about before. And then a 6-week program for research, where you'll be partnered up with a faculty member or a postdoc or research scientist at the institution that you'll be transferring into. And that whole program is paid for the summer. It's a $5,000 stipend, and we also provide campus housing for folks who would like to have it during that summer. And as I mentioned, there's also an academic term component. So after you've gone through the summer and you've settled into your classes, we'll have support for you in terms of tutoring, in terms of continued professional development and community building throughout that time in that first year. And then in addition, we'll have plenty of opportunities for information and mentorship by some of the other members of our community. So, peers in the program, graduate students, faculty, and talking about ways to succeed, not just in your major, but also going on to thinking about scholarships and fellowships and graduate school and careers afterwards. So why should you get involved? So obviously there's some money involved, so that's a great reason to get involved. It's an opportunity to do research, but it's also an opportunity to kind of get some of the resources that we know students need, particularly when they're transferring from community colleges to four-year programs. So again, that means things like paid research opportunities and information about how to get scholarships and fellowships, making sure that you have the background and the resources to succeed in your classes. It's a big jump to go from community college and then right into the upper division junior course sequence. And so we want to make sure that we're supporting you right at the beginning there. And then the other important thing is just building community. So you've already seen a community of some of your, I would say, past peers who have gone from community colleges, sometimes many community colleges, right through four-year colleges and on to their careers. And we want to make sure that you have an opportunity to connect both with your current peers, but also other folks who have made the same path, so you can learn about how to succeed in those kind of programs. And then, of course, there's all kinds of professional development skills that we'll be running throughout the year on things like how to read scientific literature, how to write papers, how to read papers, those kind of things. Karen?
Yes, so with that, we have a little timeline for you. So the deadline to apply for STARTastro is coming up. It's on May 24th, and we are accepting our first class of students. We're really excited about this, so we hope you'll give it a shot. We will plan on notifying people about whether we can accept them into the program on May 31st. And about a week after that, it'll be the deadline to confirm participation. So after that, we'll be matching people with research mentors, and the program is going to start on July 1st. So there will be 2 initial weeks of academic and research training, starting from July 1st through 12th. And then the following week, we will jump in on the research experience in partnership with a mentor that you're matched with at either institution. And that will be a 6-week program. In mid-August, we're hoping that everyone will present their research at the Summer Undergraduate Research Conference. And then we will wrap that up as you get started on your first day of classes at either institution, a bit later at UCSD than SDSU. But that is the plan. So if you're interested, please take a picture of this. You can also find our website. It's really easy to remember, startastro.org. That was a really good grab there on the website name, Adam. And we hope that you will apply to join us. Deadline's May 24th.